Melanie, can you read us the objective? On three, 1, 2, 3. That's correct. I can model linear relationships, also known as best fit lines. And we already introduced best fit lines sometime back on the warm-ups. We did an entire week where I gave you guys, remember when I gave you a lot of points on a graph, and I said, how can we fit a line that's straight through those points, but that it follows the pattern of where those points are going? You guys remember those? Kind of, sort of? Yes, Mr. Q. All right. So today we're going to continue with that lesson, and today we're actually going to finish that lesson. And in your FAIR model, you're going to write linear relationship best fit lines. So what are best fit lines? Definition. It says linear relationships or best fit lines are a straight line that best fits and provides a good description of the set of data. Best fit lines or linear relationships are a straight line that best fits and provides a good description of the set of data. Example. For the example, I'm going to zoom in so you can copy it in the example box. It's be on the screen over here. Those of you watching on video, it's on your screen. So if you notice, the x-axis is labeled book price over here on my screen. And the x-axis is scaled from 0 to 80 by tens. And the y-axis is labeled true value, and it's scaled from 0 to 80 by tens also. So copy that, please, on your example. I'll give you some time. All right. Let me zoom out again. And let me go over this using the definition. It says, linear relationships or best fit lines, a straight line. Do we have a straight line? Yes. That best fits and provides a good description of a set of data. The set of data are all the points. That's a set of data. And it's describing this line is following the pattern of these points. So first of all, if I was to scan this from left to right, and let me show you here with my little scanner. I'll start about right here because this is my first point. Then this one, this one, this one, this one, this one, and then that one. What do you guys notice? I'm going in what direction? Up from left to right. So that's why when I sketch this green line, I sketched it from the bottom going up. Because if I was to see that the points would start over here going this way, then I would sketch it starting from the top going to the bottom in a downward direction. Okay? So what else do we notice? We notice that, and I explained this last time when we saw this, that the data split evenly. Look up. Look at this line. How many points are above that line? 1, 2, 3, 4, 5. How many points below? 1, 2, 3, 4, 5. So it splits it evenly to both ends. What else do you notice? That the distance from the line to each point is pretty close to the distance to the line of each point on this side. That's how we know that it's evenly distributed. So what is the first thing that we notice? That it's a what? A straight line. And it best fits to provide a good description of the data. So let me show you a non-example. Let's see if you can tell why that's not a best fit line. Tell you never why that one's not a best fit line. Obviously, right? So copy that. Yeah, it's not a straight line. So it's obvious as to why it's not a best fit line. Did it evenly divide the points above and below the line? No. So it's way off. Copy that. And as you're copying that, we already know why this is an example of best fit line, why this is not. So let's say you were to take this picture and send it through Snapchat, Instagram, WhatsApp, or Kick people. I don't know what else you use. G4, G+. Hashtag it. What would make this a best fit line? Hashtag what? Jerry. Evenly divided, okay. Hashtag evenly divided. Hashtag what? Go ahead, Mia. Straight line. What else? Leslie. R. Hashtag what? Be nice. Help her out, Leslie. See? Bam. Best fit. We'll stop right there, right? Yeah? So yeah, this line best fits the data. It's a straight line, and it's evenly dividing the data top and bottom. Yep. All right. Let me forward your screen. Now, for this next problem, turn your page over, and you're going to copy this one in the back of your prayer model, so that because we're going to have to do a graph from it. Okay, you guys want to write this whole thing down? No, just copy the table. That's fine. I'm going to say, Paulina for Presidente. So, yeah, just the table. Copy it. Example 1. Example 1. Let me zoom in. Should be on your screen, but if you can't see, it's up on this screen. Copy that. I'll give you some time. Go. Okay, everybody done? All right. So, here goes the problem. It says, heartbeats. In this task, you will use data to create a model that shows the relationship between animal body weight and pulse rate measures. Then you will examine additional data to evaluate your model. Here's what they state for this data. It says, a study states that the relationship between animal pulse rate and a body weight is approximately linear. Let me repeat that again. A study states that the relationship between an animal's pulse rate and body weight is approximately linear. What does that mean, linear? Talk to your neighbor. Linear. Yes, that if we were to graph all the points, we would get a what? A straight line. Or what do we notice about straight lines? That the slope, remember the definition of slope is a constant rate of change. That means it makes it a straight line. That's what linear means. The study data are below. So here's the data. So for tonight, I'm going to have you plot points, sketch a best fit line, and write an equation from that line. So we're going to do this for this example. So I'm going to, let's see. Before I get the graph going, look up, please. Here's a table. If I was to ask you to graph these points, tell your neighbor which column you're going to label X and which one you're going to label Y. Okay? Did everybody say that body weight is X and pulse rate is Y? That is correct. Label that, please. Now, one thing to notice, though, on all the X values, who notices that all these numbers are what? Very good. They're different. What else do you notice? From least to greatest, what else do you notice? That they are all positive. Very good. Isn't 3 a positive number? Therefore, our Kelsey, be nice. Our x-axis, we're only going to sketch from the point of origin to the right for only positive numbers. So if you don't have space on the right, sketch that underneath. How about for the y value? Look up. What do you notice on those numbers? They're all what? Positive. That means we're going to go for the point of origin and up. So that means we're only using quadrant number 1. There it is. All right, so we're going to label this one X, and underneath leave a little space, and this one's average body weight. For the Y, we're going to label this average pulse rate. Okay. So question, and this is a very good question that you should always ask when you're about to plot data that they give you. Question. Don't I need numbers here so that I know where I'm going to plot stuff? Yes. Okay, so question. I can give you the first number. There it is. Boom. However, look at the range or look at the different values in the X column. It starts at 3, it goes to 28, and then all of a sudden it goes all the way up to 521. Talk it over to your neighbor. Let them know what would be a logical scaling that we can get on the X-axis. What would be a logical scaling? By how many? Talk it over. Hands if you agree with 50. Yes, let's go 50. So then we go 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550. All right, with that same idea, look at the y-axis. What are we going to scale the y-axis if it starts at 34 and it goes all the way to 130? Talk it over to your neighbor. What are we going to scale that at? Look at the numbers. 30, 66, 48, 95, 75, 130. What would make sense to scale that at? 10th, I would go with 10, but then I'm going to end up with 13 tallies or 14 tallies. 20, it's only about 5 to 6 tallies. 15. Therefore, we need to compromise and say, you know what, 15, because look, doesn't 15 fit into 34? About 66? About 75? And so on and so forth. Let's go by 15s. This is 15, 30, 45, 60, 75, 90, 105, 120, 135. And I'll stop right there. Okay, now that we have that, I want you to plot those points onto your graph. Go. I'll give you some time. So I'll get you started. I'm going to start with the first one, 3, 130. 3 is about right here. 130 is about right there. Okay. The next point is 2875. 28 is a little bit more than half here. 75 is about right there, so I'm going to apply it right. Okay. Next point is 5675. 5675. It's right next to this one. The next one is 192.95. 200 is here, so 192 is right before that. 95 is below 100. So 192.95, it's about right there. 362.48. 350, 360 something's about right here. 48, here's 45, a little bit further up, right there. Okay. 465.66. 465.66, about right there. And 521.34. 521.34, it's about right there. All right. So, take your pencil from far away, scan those points, start with the one that's farthest to the left, and then start moving in the direction that the points are moving at. Is it going up or is it going down? Down, that is correct. So we're going to start with our line up there going downward, right? So watch, before you sketch your line, let me sketch a line. Here it goes. Look up. I'm going to start up here. Can it go like that? No, because it's going down. So let's see. Is that best fit? About there. About there. Before we move it more, tell your neighbor why that one's not a best fit so far. Okay? So what do I need to move now? Don't I need to move the y-intercept? Yeah, I'm going to move it down a little bit about right there. Is it close? Okay, now I'm going to move this one down a little bit more. About right there. How many points above? 3. How many points below? 3, and it's going through this point. I think that's the best fit line. So I want you to sketch yours. Start at 120 and go through the last point. See if it's a straight line there. And the last thing that I want you to do tonight is write an equation given that. So let's think about it. How do we write an equation given a line? Everyone. What do I write first? How do I write an equation for a line? Very good. Kelsey said y equals mx plus b. Yes, anytime you need to write an equation, we need to write the slope-intercept form, yes? What is it that we need from there? We need a slope and we need a what? A y-intercept. So I'm going to bring down the things that we already know. The y, the equals, and the x. Okay, that stays the same. What else can we get from this line? Can we get the y-intercept already? Yes, what's our y-intercept? 120. So I'm going to put plus 120. What are we missing? The slope. But don't we have a formula to find the slope? Yes, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What does that mean? That I need how many points? 2 points. Do we have 2 points on this line? Yeah, what is my first one? The y-intercept. What is the coordinate for the y-intercept? For the y-intercept? 0, 1, 20. That is x sub 1, y sub 1. What is my second point on the line? The one that we went through, the last one, this one. And what are those coordinates? 5, 21, 34. 5, 21, 34. That's x sub 2, y sub 2. Now that I have those values, I'm going to substitute those values in here. Here we go. Y sub 2 is 34. Y sub 1 is 120. X sub 2 is 521, and x sub 1 is 0. Let's see. So 34 minus 120, that's negative 71. Is that correct? 84. 84? 86, okay. And 521 minus 0 is 521. Let's see, can we divide these evenly by 2 or 3? Nope. So we'll leave it at that. So my slope is negative 86 over 521. This is my equation for this best fit line. On your screen, I'm going to give you a set of data. I want you to sketch me a best fit line. It's on your screen on your iPad. Draw that and send it in. Draw the best fit line. Wait, can you draw on it? Oh, sorry. There it is. METRU. U. Just send me your best fit line as soon as you draw it. Press send, and then go ahead and log out. Now, for tonight, that's all you're doing. Tonight, you're plotting your points, sketching your best fit line, and writing an equation from that line. So what is the information that we need to write the equation? Slope-intercept form, the y-intercept, and the slope. Okay? There's a play sheet over here on your way out. Grab one. There is tutoring today. If I don't see you guys tomorrow. Bye.